Okay, so here we have a circuit and we want to find the voltage and the current through each one of these resistors. And we are asked to put all of our information in a table like the one that I have here to the right of our circuit. So a couple of things I like to do to start this problem is one, I like to define which number resistor each one of these resistors is, and so I'm just going to label these. So this will be resistor, I'm going to say that, let's see, this 12 will be 1, the 4 will be 2, the 24 here will be resistor 3, and then we'll have 4, and then down here we'll have resistor number 5. The other thing I like to do, so if we did that, we can go ahead and write in the resistance for each one of those. So for resistor 1, it's 12 ohms. Resistor 2 is 4 ohms. Resistor 3 is 24. Resistor 4 is 5 ohms. And resistor 5 is 3 ohms. The other thing I like to do is go ahead and pick a direction for current. And even if I do not know, or even if I get the direction of the current wrong, it's okay. It'll come out in the wash at some point. Okay, so starting here with the 12-volt battery, I think I'm going to go ahead and guess that the current will be in this direction. And I'm going to call this current, since this current also goes through resistor 5, resistor number 5, it's also going to be the one that goes through this other battery here. I'm going to call this we'll call that I5. When the current gets to this first junction here, it has a couple of different pathways it could take. One is it could go up in this direction, and then it's going to meet another junction. Or it could go down through the 12 ohm resistor, so I'll call this one here. We'll call it, no, I don't want to update. Go away. Really? Okay. So we'll call that current, we'll call that I1. I sub 1. The current could also go, let's say, through this, through resistor number 3. We can call that I3. And then we have I1. The next pathway it's going to take is into I4. Okay, or it could have gone down this resistor I2, I sub 2. Okay, and there's a couple of relationships that I can see after doing that work. One of them, for example, I see that I1, if I take I1 and I add that to I2, that needs to equal I4. Okay, and then I also see that if I take I4 and add it to I3, I should get I5. Make sure that you can see those relationships. So I'm taking I3, which is up here, and adding it to I4 because of this junction here, and I should get I5. So I3 plus I4, I3 plus I4 equals I5. Okay, you may see other relationships, but I'm going to leave it at that for now, and we could come back to this if we need to. So after I've defined my direction for current and I've labeled some things, even if you don't have everything 100% right at this point, it should come out in the wash. If you pick the wrong direction, you'll get a negative value. All you have to do is make sure that your current is, once you define your current, that it continues to go from high potential to low potential. So for example, so I define current to go in this clockwise direction. And then let's say the pathway going through the 3 ohm resistor, it didn't go back in the opposite direction. So it didn't come from this junction here and go to the left again. That did not happen. I didn't define it that way. Okay. So the next thing to do is to start reducing our circuit down to just a single resistor and our batteries, our 2 batteries here. Okay, so to do that, I'm going to go ahead and combine resistor 1 and 2 first. You can see that they are in parallel with each other. I just picked them for convenience. They just look easy to combine, so I'm going to combine 1 and 2. Okay, and if I do that, then the circuit that I'm going to have should look like this. I'll have my 12-volt battery. Yeah, so 12-volt battery. And then from the 12-volt battery, I'm going to have my resistor 1 and 2 combined. So it should look something like this. And from here, so this is, we'll call this R12 for now. And then from here, we go to our 5 ohm resistor, which was R4. This one here is R4. Okay, in parallel with those two, we've got the top resistor, the 24 ohm resistor. So up here, we have this 24 ohm resistor that was R3. And then from there we have our 3-volt battery right here. And then from there we've got our 3 ohm resistor, or that is R5. This is R5. Okay, we can figure out what R12 is. If we combine those in parallel, then we need to add up the inverses. So what we'd have here is 1 over R12 is equal to 1 over 12 ohm plus 1 over 4 ohm. So 1 over 12 plus 1 over 4. This is going to equal 4 over 12. And so that means that R12 then, if you take the inverse of 4 over 12, you're going to get 3. That equals 3 ohms. Okay, from this point, I'm going to go ahead and combine R12 with R4. And if I do that, then the circuit that I will have looks like this. Again, I've got my 12-volt battery. And then from here, I'm going to have, this is we'll call that R124. And then in parallel with that one, we still have our R3 resistor. This is R3, and then from here we've got our 3-volt battery, and then we have R5 down below. This is R5. Okay, when I combine the two resistors in series, then I just add them up. So R124, that equals the 3 ohms that we just found for R12. So 3 ohms, and then we add that to R4, which was 5 ohms. 5 ohms. So 3 ohms plus 5 ohms gives us 8. So R124, that equals 8 ohms. Okay, from here, it looks like I can combine R124 and R3. Those two are in parallel with each other. And so I'll be left with, so we'll have our 12-volt battery. And then when I combine those two, I'm going to have this is 1, 2, 4, 3, I guess, if you want to call it that. And then below that we have our 3-volt battery, and then in series with everything we have R5. This is R5. To combine R124 with R3, we need to take the inverses. So 1 over R1243 equals 1 over 8 ohms plus 1 over R3, which we said was 24 ohms. All right, and so this will equal 4 over 24. And so that means that if we take the inverse of that, that means that R1243 should equal 6 ohms. And then one more that we could combine if we want to. We're going to combine we're going to combine all of them. So we'll have our 12-volt battery, 12 volt battery, and then we're going to have our equivalent, and then we will have our 3-volt battery, and so our equivalent is going to equal, if we just add those up, it's going to be 6 ohms plus R5 was 3 ohms, so that gives us 9 ohms. So our equivalent is just 9 ohms. Okay. So from here we can start figuring out some values. Okay. And so what we're going to do first is figure out what is the current going through this circuit. All right. So what is the current going through this circuit? Okay. And if I look back at my original circuit here, the current that is going through the 12-volt battery is I5. And so if I figure out this current here, then I know what I5 is. Okay, and so how can I do that? Well, I know that what I can do here is I can use our circuit, one of our circuit laws, Kirchhoff's loop laws. Delta V of our circuit needs to equal 0. So I'm starting with 12 volts. I've got to minus the voltage of our equivalent circuit, so I'll just use delta V equivalent. And then I have minus, I'm going to subtract this 3 volts. Okay? Anytime you go positive to minus on the battery, you subtract. If I went the other direction, I would add. So minus 3 volts, that needs to equal 0. So we have 12, so we have 9 volts minus our delta V EQ, that equals 0. So delta V EQ is equal to 9 volts. Okay, so I know the voltage of my resistor here. So delta V of that equivalent resistor is 9 volts. And now I can easily find the current. So I, using Ohm's law, I is going to equal delta V over R. And so this is 9 volts over 9 ohms. And so we get I is equal to 1 amp. And like I said, well, you'll see this here in just a minute, this is the same current that goes through resistor 5. Okay, so I figured everything out that I can with this circuit, so I'm gonna start working my way backward. Okay, so when I combine these two circuits, since they're in series, the thing that they are going to share is the current. So the current stays the same. And so I just found that current just a minute ago. I is equal to 1 amp. And this is equal to the current going through resistor 5. So 1 amp. So I can come up to my table here. And for resistor 5, we know that I is equal to 1 amp. And since I know the current and I know the resistance, then I can figure out delta V of resistor 5. And so if I want to do that here, delta V, right, delta V of resistor 5 is equal to I times R. So we have 1 amp times resistor 5 is 3 ohms. So 1 times 3 ohms, that gives us 3 volts. So I can write that in up here also. So we have 3 volts for resistor 5. Okay. The other thing I can figure out about this circuit is what is delta V of this other resistor. All right, so delta V of 1, 2, 4, 3. Again, this is just I times R. So this would be 1 amp times 6 ohms. So we would get 6 volts. That should still obey Kirchhoff's loop rule. So we would have 12 volts minus 6 volts minus 3 volts minus 3 volts gets us 0 again. So that worked out. All right, that's all I can really find out about that circuit. So I'm going to move up here. Okay, we still know I5. That didn't change. All right, so the current going through this stuff is still I5. Okay. What is similar about these two resistors is their voltage, because they were in parallel. So I can, since delta V of these two in parallel was 6 volts, then delta V of of resistor 3, it still needs to be 6 volts, and delta V here is also 6 volts. And so I can figure out the current going through each of those resistors now. All right, and so this one here would be, we could call this I3, and I3 needs to equal delta V over R. So we would have 6 volts over resistor 3 is 24 ohms. And you can leave this as a fraction if you want to. I'm going to. So I'm just going to simplify it. So this would be 1/4 amp. You could write 0.25 amps if you wanted to. I'm going to leave it like that. We can also figure out the current going through this resistor here. This would be you could call it I124 if you want to, and that would be delta V over R. So that'd be 6 volts over 8. So that would be 3/4 amps. Okay, and remember that since at this junction we need the sum of the current that's going into that junction needs to be the sum of the current going out. So if we take I3 plus I124, we should get I5, and we do, because 3/4 plus 1/4 is equal to 1 amp, so that works out. All right, I know everything about that circuit. I'm going to keep moving up. Okay, again, I already know delta V R3. We just found that, right? Delta V was equal to 6 volts, and we found I is equal to 1/4 amp. Okay, since these two were combined in series, then the thing that stays the same is the current. So again, this was I124, is equal to 3/4 amp. And so now I know what I4 is, right? The current going through resistor 4. So I can come up here and I can write the current going through resistor 4 is 3/4 amp. I forgot to write stuff in for resistor 3. Resistor 3, I3 was 1/4 amp, so I'll write that in. We have 1/4 amp, and we found the delta V was 6 volts, so I'm going to write that also. 6 volts. Okay, looking back here again, I know the current going through each of those resistors, and I know the resistance, so I can figure out delta V. Delta V of R12, so delta V12, this is current times resistance, so that's 3/4 times 3 gives us 9/4 volts. And then for R4, delta V4 needs to equal I times R, so you're going to get 3/4 amp times R4, which is 5, so that gives you 15/4. 15, so we have 15 over 4 volts. Okay, that's everything I can know about that circuit. Notice this actually gets a lot easier the more information you find. It just kind of starts snowballing. So resistor 4, we just said delta V is 15 over 4 amps. Oh no, not amps. 15 over 4 volts. Okay, and then moving up one more time here, we have our original circuit. And for resistors 1 and 2, they were combined in parallel, which means that they're going to share the same voltage. So delta V of resistor 2 is going to be equal to 9/4 volts, 9 over 4 volts. And delta V1 needs to be 9 over 4 volts. So to figure out current, we know the resistance, we know the voltage, we can figure that out. So I'm going to do that down here. Everything's getting kind of cluttered. So so I2 is going to equal delta V over R, so we have 9 over 4 volts, divided by the resistor is 4 ohms, and so we're going to get 9 over 16 amps. And then for current 1, I1, we are going to get the same voltage, so 9 over 4 volts, and we are dividing that by 12 ohms. All right, and so we would get 9 over 48 amps. Okay, so not very pretty there, but that should be right. So again, I1 we just said is 9 over 48 amps. I2 should be 9 over 16 amps. Delta V1 we just said was 9 over 4 volts. And delta V2 also 9 over 4 volts. Okay, you can check your work. I'm not going to do it just because this video is already pretty long. What we should notice though is I1 plus I2 needs to equal I4. We might as well just check that one just in case because those currents are kind of weird. I1 plus I2 needs to equal 3 over 4. All right, so 9 over 48 plus 9 over 16, that needs to equal 3 over 4. I'm going to just put that in my calculator just to be sure here. And we do, we get 3 over 4, so that checks out. I encourage you to check out all these other values, make sure that they are okay. It's always a good practice because it's very easy to make a small mistake, and it's usually not an error in you actually setting up the circuit. It's usually some kind of math error. So make sure you check this, make sure your values match up.